Hello, this is Jeff with nybbles.io, and I'm doing a video here on request from Gun Games about SDL2 timers. So there's actually two ways that we can do timers, and one of them really doesn't have that much to do with SDL, although SDL has a function, SDL get ticks, which we can use to implement that. So, but SDL also has a built-in timer mechanism. And the built-in timer mechanism is thread-based. So they have a background thread that is running their timer loop. And as you add timers into their system and remove them, that's all that timer thread does. Is it just loops over those, checking to see if they've expired and need to be called, the callbacks need to be called. The trick is, because they're in a different thread, we have a thread marshalling issue that we have to deal with. Now there is a solution to that problem, or at least one that I've found that works. So I'm going to demonstrate the way that you would use the SDL2 timer mechanism that uses that background thread. However, really briefly, you can also build your own timers, and it's really very easy to do. So what I did was I created a test program. I pulled in the SDL2 dependency and added that to my build. And so I have a simple test program now that does this. It just has a little cube that is bouncing around rather slowly on this display. That's all it's doing. Super simple. And this is what we're gonna build our test around. So to build timers without using the thread-based solution that SDL provides is pretty trivial, right? What we could do is you're going to have your event loop, right? So somewhere in your code, you're going to have this loop where you're checking for events from SDL, where you're clearing your render or your surface or whatever, and you're doing your drawing, and then you're presenting, right? And then you go back and you loop again. And presumably, you have your presenter or your renderer set up to present on VSync, and so then you're locked to whatever the frame rate of your display is, 30 frames a second, 60 frames a second, whatever, or you're doing some kind of tweening. You know, you're checking delta time and you're passing that everywhere so that you can adjust your simulation so that your frame rate stays constant. Either way, you have some loop like this somewhere in your code. So if you want to do timers, all you have to do is you don't want to use necessarily the thread-based solution that's built in. Create a struct that represents your timer or class, whichever you prefer, and have a collection of them. Have a way to add and remove instances of this timer class to that collection. When you create a timer and you prime it, however you do that, you call SDL get ticks, which is the number of milliseconds that have elapsed since the program started. And that value wraps, if I remember correctly, like every 30 days or something. So if your game ran nonstop, for 30 days, that number would wrap. So there's only one wrap occurrence in 30 days. And you would just store whatever the current time is. When you set up your timer, you configure how long you want your timer to run before it elapses. And then in this event loop, you would just loop over your timer types in your collection and say, okay, is the current time, has this thing elapsed? If it's elapsed, then you have either a pointer to a function or you have a standard function or whatever on that thing. You call your callback. Typically, the callback can either, you pass in a pointer to itself, or you return true to keep the timer going, or false to kill it, or there's a variety of ways you can do that. But you can make timers that are very accurate, they're frame accurate, and have, I think SDL can get down into the single digit millisecond accuracy. And you know, you can build fairly complex games that way. And it avoids the thread marshalling issue, which we have to deal with anyway. So just without going into writing the code to do that, that's a way that you could make that work. Now, and I'm actually thinking, because the way I'm going to have to end up marshaling from the thread, yeah, you know, I'm going to go ahead and do it. I'm going to do it without the thread first, because I'm going to need that anyway. I need a main thread implementation regardless. And then we'll add the capability to support the SDL thread. So here's how that's going to work. So I'm going to create a struct called timer key, and it's going to have SDL get ticks. Yeah, this returns a UN32. Okay, so UN32T is we'll call this last time. UN32T expiry time, UN32T duration, and then since I'm doing this with C++, we'll have a standard function that returns a Boolean and takes in a timer T pointer like that. Include the header. So this is our timer struct, okay? Really simple. And let's put a flag on here, enabled. Okay, and then we need something that manages timers. Again, this is a very simple one file test. Obviously, if you were building something that was larger, you know, you would put these things in separate files, and you'd have to deal with the header file stuff. But I'm just going to call this timers, plural, and this is going to have a vector of timer T pointers and default constructor, and I need to include vector. And you know, now that I'm thinking of it, let's make a type def timer st. And we need a constructor on this guy. We're going to loop over timers, and we're going to delete the timer. Okay. So what do we want to do? We want to be able to make a new timer. So let's add a function in here called start timer, and it'll just be two things. It'll be, and actually while we're in the mood of creating type defs, timer expired callable. Okay, because we're going to need to use that a couple times. timer expired. So this will be the duration and a const timer expired callable like that. Just save it. Okay. So we'll set it to enabled. Last time is going to be SDL get ticks. And duration is going to be the duration we pass in. And expired, or expiry time, is going to be timer last time plus timer duration. And the callback is going to be the callable that we passed in. Just like we return back the pointer, but we also add that pointer into our list, okay? So now this timers thing, we can start a timer, we're going to get a pointer back to it. So if we want to change it or adjust it or whatever from the calling scope, we can. But the timers class itself is going to keep track of that. So then we need a just an update, right, on timers. And what's this going to do? This is going to first call SDL get ticks. We don't want to call this too much. This function does have some weight to it depending on platform in terms of how it's computed. So it's best to call it once if you can, and then just use that. You're going to get a little bit of drift, but it's not a big deal. So we're going to grab the current time. We're going to loop through the timer pointer list here, and we're going to say if timer expiry time is less than now, then it's expired, okay? So now we could say less than or equal. I would just probably say less than. That you might technically miss, a firing here and there when you would expect, but we're talking on orders of, frame time here. So at 60 frames a second, like 16.66 milliseconds, we're talking about a relatively small amount of drift. So, especially for games, right? I can imagine some games maybe where you need like sub 10 millisecond accuracy, but you can probably get by without that. So if it's expired, what we're going to do is we're going to invoke the callback, passing in ourselves, okay? Why pass in ourselves? We're passing the timer. Well, because then the callback can do whatever it wants. The callback can change the duration, it can change the expiry time, it can change the callback, it could do all sorts of things. It could disable the timer. So that's the other thing. If the timer is not enabled, then we're just gonna skip it. So that means someone on the outside would have to re-enable that timer once it's been disabled. So here's another interesting thing. On the callback, the more I think of it, we probably would like to pass in the timers class as well. So we're going to pass in the timers and the timer instance that is being fired. Why do both? Well, then inside of a callback, you can now start other timers. Right inside your callback, you have access to the timers class, and you can start timers, stop timers. So that's the other thing. Let's put a uint16t ID on here. Okay, and then again, for this really simple example, I'm going to have a static inline int or uint16t sid is equal to 1. And when we create a timer, we will do id equal sid plus plus. So every time we create a timer, we get a new ID. And then timer map t standard word map uint16t timer t. Then we might want to be able to get timers back by their ID. So, oops. Let's pull in, oops, no, come on. There we go. Pull in an unordered map. So we'll change this a little bit. Actually, let's not. We'll keep the list. The list is where, that'll be our ownership list. In other words, the pointers that the class owns that it needs to delete, that's where that will come from. And we'll also have a timer map t that is id to timer. And so here, timer or id to timer, insert, make pair, and this will just be timer id, comma, timer. And because we're using pointers here, we can kind of index this thing a couple different ways. And so then we could do timer t find by ID. Oops, there we go. So we can look up a timer by its numeric ID. And while we're at it, another good thing probably would just be a timer list t, except we're going to make this one a const reference because we don't want to be able to change the list inside. We just want to be able to let the outside world get the list of timers if it needs it. Let's call this timer pool. It's and then we have to forward declare timer pool. There we go. Because I'm thinking you're only going to have one of these timer pools here. You're not going to have many, although you could have different subgroupings if you wanted. You know, again, the usage scenarios are pretty much endless. So this gives us a pretty functional, I think, setup. The last thing would be remove timer. And of course we could do this both by ID and by pointer. We'll do it by pointer here because it's I think it's a lot easier. So first, what we would want to do is from the timers, we would want to erase. So this is going to be timers begin, timers end. I think we're going to do Yeah, we want to do find if and okay. So that will remove it from the list. We then want to delete it, but then we also need to remove it from this, like that. Okay, so this will erase it from the vector. It will get, the iterator will get returned. If it wasn't found or it wasn't erased, then it would be at the end. If it's not at the end, then it's true. And then we also remove the key for that timer, and then we finally delete it, and then return true or false. Okay, I think that's a complete, credible little timer manager thingamabob there. So then for our test here, we can just create a timer pool up here, and let's create a single timer that is 250 milliseconds, and our callback is going to be timer pool pointer and timer t. Okay. And let's have this just occasionally, well, we'll just have it every time this triggers. We'll have it change first dx. We'll invert the dx delta for our little block, okay? So that's the first. So now nothing's gonna, it's not gonna do anything different. It shouldn't, because I haven't actually wired up the timers. So first in our loop, right, so this is our main loop, we're gonna call pool update. And that's going to loop through. Now, we hadn't finished that. Let's go back to that, right? So if it's not enabled, we bail on it. If it's expired, we call the callback. If it's false, then let's say that if the callback returns false, it disables the timer, okay? The timer's still there, it just disables it. So that's like a quick and easy way to turn the timer off. Otherwise, right, and here we don't try to reset anything. Otherwise, we're going to set the expiry time equal to now plus timer duration. Okay, this is the next expiration. And we keep looping through timers, doing that, and we're only going to have one timer here for now. Okay, so now we're calling timer pool update. We're doing our event processing, we're doing our rendering, and so let's see what happens. Yeah, there you go. Now we get we get some interesting behavior, right? Every 250 milliseconds, we're changing the X delta that gets added to our little block. Now, let's say that we wanted to cascade things, okay? Let's say that we wanted one timer to beget another timer, but that other timer only happens under certain circumstances, or it happens one time, maybe. So that's another interesting piece. We should probably put some kind of, let's put a 32-bit data 1 and data 2 on here. So we can, we have 8 bytes that we can use on the timers for whatever user data we want. Let's say well, actually, let's do this. Let's have this timer run for 1 second. And what this will do is this will change the color. It will cause the color to fade down. Of course, eventually, so we'll clamp it. It'll come down to really, really low value, but so if we watch this, slowly it's getting darker. Yeah. Every second it's dimming. But now what we'll do is, if the green value is below or equals some value one time, then we will kick off another timer. And when that timer finishes, it will reset the numbers back to their original, and then it will destroy itself. We'll get rid of it, okay? Okay, it's very subtle. Now, here's an interesting part. We don't want to destroy so here's what we should do. Mark for remove. So let's make another list to remove. Because we're inside of a callback on this heap allocated thing, even if it were on the stack, we don't want to kill the thing while we're in the thing. So instead, when we're inside of a timer, right, we will have this mark, and then what we'll do is in update, we will loop over, we'll call remove timer on that, and Let's you know what? Never mind. I'm silly. Let's do it this way. I just realized we're gonna clear the end. We're gonna clear it anyway, so it doesn't really matter. Right. So we're gonna call remove timer on every timer, and then we're going to clear to remove because we don't want that to persist. Those are gone. So then during a callback, we can safely call mark to remove or mark for remove. And then during the next update cycle, those things will be garbage collected. Those things will be removed. Okay, so then let's say here, if first color G is equal to, and what does G start at? 38 hex. Let's say if it's equal to, well, we'll say if it's equal to 10 hex, then we're going to say timer pool, start timer, and this one will make for, I don't know, 4 seconds, okay? So 4,000 milliseconds. And the callback on this guy call this timer pool 1 because we got some nested callbacks here. And then we're going to do timer pool 2, mark for remove, reset timer. And then, but before we do that, we're going to set first color red as 0x9a, first color green 0x38, and first color blue FE. So we're going to reset the colors. When we get to 0x10 for G, then we're going to start this timer, and 4 seconds later it will reset the colors on the block and then remove that timer from the pool, return false, and which will immediately disable it. So just in case there's some hinkiness, right, because the delete or the remove won't happen until the next frame. So that's safe. And yeah, so let's see what that looks like. So yeah, it's not really very visible, unfortunately. I can see a subtle color change, but it's very, very subtle. What can we do here? Well, I guess if we just change green, right? That'll be that'll make a more garish color change. Okay, so now, yeah, that's not doing anything. Okay. We'll put a breakpoint there. All right, so we are getting into the callback. So then are we ever getting here? Ah, we're never getting there. Okay. Actually, let's, because it is 1 second per. It is changing it. Okay. Huh. Weird. I'm not really seeing any change. I'm wondering if I'm having a copy issue here. Oh, there it goes. All right, so it is changing the color values. But for some reason, okay. I think they're wrapping is what's happening. All right, let's do it this way. Instead of checking for the actual color value, which is probably wrapping, let's use our timer. So we get back the pointer. So color magic timer data 1 is equal to 20. Actually, let's do 32. Okay. So if timer data 1 is greater than 0, then timer, no. If it's equal to 0, so we're just going to do color stuff here. And then on our timer, we're going to subtract 1 from data 1. So instead of, because I think what's happening is we're doing the color stuff frequently enough. These are bytes, they're wrapping. It's a timing thing. Timing thing with timer. But this is a 32-bit value. It's not going to wrap so quickly. That's my theory anyway. Oh. Okay. Okay, so we're starting a timer here. Except, so if okay, so this first timer we call timer. If its data 1 is 0, we start another timer, which 4 seconds later kicks off, which resets the data 1 on the original timer to 32, resets all the colors, removes timer 2 from the, removes the reset timer, this thing that we're creating. It removes itself from the pool because we don't want it to continue, we don't want it to be there anymore, just to kind of demonstrate that. Otherwise, we change colors, and so if okay, so we're going to increment the colors, each color component, and if it's beyond 254, we're going to reset it to 5. So red, green, blue. All right. All right, so for some reason, this timer, and we're creating it now, but so the timer list here, oops. Okay, there's one timer. Now there's two. All right. Now there's three. You know what I should do? I'm going to call getTix here, and last time should be timer expiry. All right, so I've got a callback here. I'm going to set that to 1 second, and I'm going to set this to 500 milliseconds. Oh, yeah, okay. Color magic timer. Can we do that one? Okay, there we go. So it's 500 milliseconds times 32, that's 16,000. That's 16 seconds. And then another second for this timer to kick off. Interestingly enough, the debugger seems confused about where it's at. Oh, yeah. Okay, so if data 1 is 0, we're going to bail. If it's equal to 1, we're going to start this other timer. And so we're going to count, we're going to change the colors. Then we're going to, when this reaches 1, we're going to start this timer. And then we're going to subtract or just set it to 0 here, okay? And then while it's 0, we're waiting for this other timer to trigger. That's what was happening. Because it was always 0, we were creating more timers. And so then this should then trip, reset data 1 to 32, and the process should repeat. And then I'll see what I can do about making it more visually interesting here. Okay. Yeah, the debugger doesn't handle that nested lambda very well. But if I put a breakpoint in update, the size is 1, then it's 2, then it's 1. Okay, now we're removing 1. Yeah, okay. So the counts are right. I need to just make it more interesting visually. So let's subtract from blue. Okay, the color's changing. That's a little better. Yeah, there we go. Now we're getting, and it resets it. Now, when it resets the color, let's also have it change the, yeah, see, there it goes. There's the second timer, it's resetting it. But let's also have it change the, let's have it invert dx and dy so we can see some other, something a bit more tangible on the screen. So this is in the second timer that's kicked off from the first timer. Okay, so color's going to change, we're going to reset, and there it goes. Then we change direction, and we're going the other direction. And then the color changes slowly, and then we reset. So that's an example of how you would build an event loop set of timers, okay? Now, we need this anyway, because, or you need something like this, because again, the built-in timer mechanism in SDL is thread-based, and you're going to have all sorts of interesting issues. You can't call, like most of the SDL graphical stuff, off the main thread. It doesn't work. So you're just going to have all sorts of problems. So the way that you would do this is you would, in the thread-based callback from SDL, you would push a user event structure onto the SDL event queue, which is thread safe, and then in your regular event thing, you would process it, okay? So how could we do that? Well, we already have the mechanisms here to do this. So what we could do is set color magic timer enable to false after we create it. And then the SDL, I think it's called SDL add timer. So SDL add timer. And this has an interval and has an SDL callback and a parameter. So let's set this at 500 and okay, so we need the callback function. So here, let's create static 32T SDL timer callback. We only need one of these. Interval and a void pointer to a parameter. And this is going to be the pointer to our timer. So in here, we want to create an event and a user event. And we want to set the user event type equal to SDL user event. User event code is 0. The data, first data and the second data are null. And then the event wrapper is an SDL user event, and user is user event. And then we would do an SDL push event, passing in the address of event, and we just return back the same interval. That keeps the timer going. Okay, so what we're going to do is this is going to be SDL timer callback. This is going to be color magic timer. Now for this example, I'm just going to put this one timer on the, well, how do we do that? Let's do this. Let's call this bounce, reset and bounce timer. Reset and bounce enabled false. And then here we do the same thing, right? So this should be 250 and this should be 5, or what did I have this, 1000. And instead of passing color magic, we pass color reset bounce here. So what this SDL add timer is doing, this is adding an internal structure inside of SDL. It's keeping track of these. In fact, if you look at this, it returns back an ID of that timer, right? So you can refer to it later to remove it. And in fact, add timer is very much just like our start timer. It's just a procedural call. And behind the scenes, right, SDL is keeping track of that for you. Now, what we want to do though is well, our timers are disabled. Yeah, okay, here's what we can do. Auto SDL timer ID and timer data 2 can be SDL timer ID. And then here, because we're removing this, we have to remove it from our thing, and we have to call SDL remove timer. And it's timer, or reset timer data 2. That's their ID. So this is an example of how you would piggyback an event-based main thread timering system onto their thread system, okay? So then what's gonna happen is when these timers fire, okay, we're getting a, we're gonna get a user event here. So let's do this. So if we run that, and I got it right, which is maybe possible, then yeah. So we're going to be getting these user events, right? Because of the timer. All right. So now here's what we got to do. What we have to do is we have to pull or convert. So we want to cast. Timer is equal to reinterpret cast timer t from event, or I'm sorry, e user data 1, right? So we're going to cast that value to our timer. So now we have a pointer to this timer, and we can then just call the callback. Now, because we're piggybacking on the SDL timers in this case, we can just kind of cheat and do that, right? That's the address of it. Oh, I'm sorry, I just called it pool. So let's take a look at that. Okay, ooh, timer's null. That's not good. Oh, I forgot to set the, yep. I've been drinking again. So this is going to be param. That's what we want, right? Because we're passing in, yes, I think that's correct. Okay, so now timer should not be null. And it isn't. Good. There you go. So now, let's watch this. Color's changing. And reset. There you go. Ooh, kaboom. Okay. Oh, because yeah, this doesn't have anything to do with SDL per se. This is just because I'm piggybacking. I would say the answer here is we just don't. In this case, we're removing the SDL timer. We're not removing our timer. We leave that because it's, in our timer system, in this case, we've disabled them. So our soft timers are not executing SDL. Their timer thread is dealing with all the timing and the callbacking. Yeah. Ooh. But yes. Okay. So here's the issue. Couple issues. Yeah, and again, this is just because well, actually, yeah, see, this is where multi-threading gets to be interesting, right? We're marking it for removal, which is happening up here, but that same pointer could arrive, or could be treated as part of the threading timer system independently. Oh, yeah, and see, I think that's reset and bounce timer. That's part of the problem, I think. Because this belongs to, yeah, that belongs to that. This is the new timer. Yeah. Okay. And our little block. And reset. That looks much better. There you go. Now it's happy. I was setting the ID on the wrong thing. So that'll do it. Okay, so that gives you hopefully an idea, and I'm going to walk through the code one more time to try to explain this. And actually, let's speed this up just a bit. Instead of 250 milliseconds, let's cut it down. We'll make it 125. We'll leave the reset at 1000, so 1 second. So the color cycling should be more pronounced, and we should get more of it, and then the reset should happen Yeah. Yeah. Okay. Okay. So let's go through this. Top, bottom. I have a struct for my little block that I'm drawing on the screen. It has an X and a Y with a height, a color, and it has a delta X and a delta Y. This is the direction that it's moving. I forward declare our timer pool and the timer struct because I need to make a callable that I'm going to use in the timer struct. I need to do a type def. And we create a standard function callable that returns bool, takes a timer pool pointer and a timer t pointer. Our timer t this represents our soft timer, which we need pretty much one way or the other. Because we need to keep track of what timers we've created. SDL doesn't, it does and it doesn't, right? It's a what they offer is very, very thin. So what I would advise building your own structures around all this no matter what. So each timer has an ID, it has an on and off flag, it has the last time that it was triggered, it has the next time it will expire, it has the duration, it has 2 user data values, and it has the callback, okay? We have a type def for timer map t, that's an unordered map of 16-bit integers to timer t pointers, a timer list t, which is a vector of timer t pointers. We have a timer pool, who has a default constructor, has a custom destructor. We loop over our timers list inside of the timer pool, and we delete those pointers because we own those, we've created those. So whatever's left, we have to get rid of. And I guess technically here we should also clear this. Let's go to start timer. So start timer takes a duration and it takes the timer expired callable, which we talked about above. We create a new timer t on the heap. Why do I do it on the heap? This is just expediency, right? I'm doing this because it's quick and easy and it works without having to go through some other hoops, which could complicate the demo and, you know, make it harder to put stuff together. So we set the ID. We have a static on the timer pool class, which starts at 1 and just goes up. We turn the timer on by default. We set the callback, we set the duration, we set the last time to the current ticks from SDL. The expiry is the last time, which is right now the ticks, plus the duration. We add the pointer to our timers list. We add a map entry for the timer ID to the timer pointer. And we return back the timer pointer. We can find a timer by ID. So we go to the ID to timer map. We look up that ID number. If we didn't find it, you get null. Otherwise, you get the pointer. We return back a const reference to our timer list so that people on the outside, if they wanted to loop over the timers, they could, but they can't change what's in the list. They can change the pointer. I mean, they can invoke things from the list, right? But they can't change the list. And then we can remove a timer by passing in a pointer to it. We erase it from the ownership vector. We erase it from the map. We delete it, and we return whether or not that actually happened. Within a callback, it's not really safe to call remove timer. We have to tell the timer pool, hey, on a future call to update, get rid of this guy. So we have a mark for remove, which we pass in that pointer and we add it to that list. Then update does 2 things. First, it loops through the to remove, removes that timer. So this is, again, taking it out of the vector, it's taking it out of the map, it's deleting that memory, it's freeing it, and then we clear the list, right, because we're done with that. We get the current ticks. We loop through the timers. If the timer is not enabled, we just go to the next one. Otherwise, if it's enabled and the expiry time is earlier than now, it's time to call the callback. So then we call the callback, passing in a pointer to the pool and passing in a pointer to the timer that we're on. If you return false here, we disable the timer. Otherwise, we set the last time to whatever the current expiry time is, and we set the expiry time to now plus the duration for the timer. So obviously in the callback, if you change the duration, then the timer will behave differently the next time through. Start, we already talked about start timer. So we talked about all those. This function, this is the callback that the SDL interface for their thread-based timing system expects. You only need one of these because ideally what you want to do is you want to shuttle this callback, which happens on a different thread. You want to shuttle this to the main thread, okay? So the way you do that is you use an SDL event and you push it on the SDL event queue, and then in your main processing loop, at some point, either in the current frame or in the next frame, depending on how the threading overlaps with your main thread, that user event will get triggered, okay? And so that's it. I mean, this is the plumbing that causes the callback from the SDL thread-based timer to end up in our code. And so then in our main function, we create a pool. I create one block just for demo purposes. I have a pointer to the color changing timer that I create. So I create a timer. I set it to run every 125 milliseconds. The callback, we get a pointer to the pool. We get a pointer to the timer. And I won't go over the logic in here too much other than we have a small little state machine. If we're in the 0 state, then we bail, waiting for things to change. If we're in the 1 state, then we set the state to 0, and then we start this one-off reset and bounce timer. So we start another timer from within the original timer for another 1,000 seconds, I'm sorry, 1 second, 1,000 milliseconds. When this guy gets called back, we reset the data 1 state right to the countdown state for the colors. We reset the colors. We change the delta X and Y. We remove the SDL timer, right? Because we're kind of blending the SDL thread stuff on top of our soft timer implementation. We tell our pool, hey, this guy's done, get rid of him. We return false. And then we set the reset and bounce timer. This one we just started, we disable it because we don't want our soft timer system to run it. We want the SDL stuff to kick off the callback. And then we call SDL add timer, passing in the same timeout value here. I mean, technically reset and bounce duration, right? Because that's what it is. And then we pass in the SDL timer callback, and there's only one of those. We don't need to create multiple. It's just a utility function. And then we pass, this is the parameter that SDL will pass to that callback when it gets called. So we want to pass the pointer to our timer because that's the thing that has all of our metadata on it. This just does the timer or does the color stuff in our timer. And then same thing with the color magic timer. We should use duration there. And obviously, so you could have a config flag, right? You could move these SDL add timers and remove timers. You could put those inside of the timer pool. So it's all kind of hidden. And you could have a flag, use SDL, don't use SDL, or whatever. And behind the scenes, you could even, on our, on this timer T structure, instead of using the data stuff, because that's really for consumers, you could have a special field on here that is the SDL timer ID. So if it's enabled, would be specifically storing the SDL timer ID in one spot. I'm putting it here to kind of expose like where it's being integrated in a really obvious way. It could be refactored so that it's encapsulated. And then the rest of this code is just standard SDL. We create a window, we create a renderer, I have a running flag, I have a while loop. We call update on our soft pool. We do the standard SDL event polling loop. The only change here is we have SDL user event. and we know that our user event is coming from this timer callback on this other thread. And so we know that data 1 on that event is the pointer to our timer. So we recast it and we call the callback, and that's it. And then we set the draw color to the background, we clear the renderer, we set the draw color to the block color, and we draw the block. We change our X and Y on the block based on our delta. We do bounds checking on the position of the block, and we present the render, and then everything continues. And that's it. That's how that works. And of course, you can see, I think, that you could have an infinite number of, so now I'm actually passing the duration from the actual timer instead of they were getting out of sync. So that's better now. So you could have an infinite number of cascading timers, and you can, combine timers into your entity system or however you're doing that. And that's pretty much it. So I'm going to check this into the questions repository on the nybbles.io account on GitHub. And it'll be self-contained. SDL's in here. So all the dependencies, everything are there. You can just pull it down, run CMake, and it should build for you, assuming you have all the tools and stuff installed. This should run on Windows, OS 10, and Linux. Although on Windows, you probably would want to do like MinGW. You could probably make it work with Visual Studio, but it's going to require some changes. Because I'm using initializers and some other things that Visual Studio doesn't care for, Visual C++. But other than that, yeah, hopefully that answers the question about timers and how that can work. And you can take this soft timer approach. I personally use soft timers with everything that I do. If I was going to make a really big AAA game that, was going to have it was going to have a job system, and, there was going to be other threads doing lots of other things. If I actually felt like there was a payoff to it, I would go down that road. Quite frankly, for most casual gaming things, you really don't need it. And the threading is just going to introduce, again, shuttling it to the event system is fairly safe. I think this is going to minimize any kind of thread issues that you might potentially have, but you have to be careful, right? What you do here is extremely limited in this context. That's why basically we're taking the state, we're stuffing it into an object, and you're telling SDL, hey, do this later, right? That's about the safest that you can possibly be here. If you start interacting with other parts of your system from within the SDL callback, you have to manage that yourself, right? You have to manage that locking. So then you either need mutexes or semaphores or something along those lines to make sure that you're handling critical sections in your code properly. If you do it this way, this is thread safe, right? The SDL library says you can do this and it will be okay. So this whole approach, creating an event, pushing it on their queue, that's safe. Because then you ultimately just end up processing it when you get to it here. Now this also does imply, right, that with the thread approach, there's perhaps more slop, right? On the one hand, you would think it would be faster, but because we have to handle dealing across the main thread and the callback thread, it's possible that an event gets deferred by a frame, maybe two, depending on how exactly the timing on that works. And without looking at the code on SDL push event, it's hard to say exactly how they're making this thread safe. It probably is just has a mutex around it or something of that nature. But if it has a mutex or something, this thread theoretically could block on getting that into the queue. So, it's just something to keep in mind. With the polling based one, with the frame based one, right? This is guaranteed to run at the top of your frame. So if you're locked to 60 frames a second or 30 frames a second, you know that that's essentially your timer resolution. And if 60 frames a second on modern hardware is not a problem. So that means that your maximum slop, or I should say your minimum slop, would be about 16 milliseconds, give or take. At 30 frames a second, it'd be 33. And that could or could not be acceptable, but it would be consistent, right? With a time or with the thread approach, it might be more performant sometimes and less others. It's going to perhaps be less consistent. So your timer slop could vary depending on exactly how those things are interacting. And obviously all the SDL code's available, so you can read through it and see how that's being done behind the scenes. I haven't done that, but it's probably a generally safe implementation, but there's probably going to be some variance there. So, all right, hopefully that's a help. And this is on YouTube only. If you enjoyed the content, give it a like, share it with someone, subscribe. I'd appreciate it. I also stream on Twitch, twitch.tv/nybbles.io, nybbles.io. All right. Thanks, everybody.